This is Shuttle Launch Control at NASA's Kennedy Space Center in Florida at T-minus 3 hours in holding. We are a little less than 5 hours and 15 minutes away from the launch of Space Shuttle Endeavour on its STS-130 mission to the International Space Station. This is Endeavour's second launch attempt in 2 days, although given the time of day, it feels like it has been one long day for a lot of the flight controllers here at Kennedy Space Center. This morning at 4:30 a.m. Eastern, the first attempt was scrubbed just 9 minutes before its scheduled liftoff because low clouds unexpectedly rolled in over the Kennedy Space Center. Currently, launch controllers are not working any technical issues that would prevent us from launching on time at 4:14 a.m. Eastern Monday, but forecasters are calling for a 40% chance of very similar conditions from last night. Low clouds again around the liftoff time to prevent liftoff tomorrow morning. Managers and engineers are directing and monitoring Endeavour's countdown from firing room number 4 here in the Launch Control Center, about 3.5 miles away from the shuttle. And during the next 5 hours, we'll take a look at the STS-130 mission, its 6 astronauts, and cargo, as well as follow along as launch controllers get Endeavour ready to start its 13-day flight to the space station. This is Shuttle Launch Control at T-minus 3 hours in holding. We have 1 hour and 20 seconds remaining in this 2.5 hour built-in hold. Joining me now in firing room number 4 in the Launch Control Center is Dana Hutcherson. She's the flow director for Endeavour. And simply put, that means she's the manager responsible for getting Endeavour prepared for its missions. And thanks for coming to talk to us.
You're welcome, Allard.
All right, let's go right into it. You've got some video. You want to show us what it took to get Endeavour to where it is right now. We can start that video, and we'll take it from there. How does that sound?
All right, sounds great. Let's see, Endeavour began the journey preparing for STS-130 when it landed at KSC on July 31st. That was from STS-127. That was the last mission. And you can see here some of the operations for towing Endeavour and getting prepared for rolling into orbiter processing facility 2. So once in the orbiter processing facility, Endeavour undergoes the maintenance operations in preparation for the next flight. What you're seeing on the video here is actually the forward reaction control system. We actually had a couple of thrusters that we needed to remove and replace this flow. So you can see some of the inspections are in work. This forward reaction control system, if you're not aware, is actually what where the thrusters are housed, and that's for on-orbit maneuvering while in orbit, and that's after the main engines. You can't use the main engines anymore. So we use these thrusters to maneuver us. One of the other major operations that we did was working with the removal and replacement of the boom. And this was actually just to do some inspections that we have to do every other flight.
And the boom is the orbit boom sensor system, what we use to inspect the shuttle while it's in orbit, correct?
That's correct. While we're on orbit, we actually do 2 inspections. And the boom is just an extension of the arm that we use to wrap around to the belly of the vehicle and look for the thermal protection system, make sure everything is checked out, and make sure that the TPS is ready for reentry. So this is a great tool. It's actually, as you can see, the Canada logo on there. It's a multinational effort that we use to get the shuttle ready for flight and in preparation for the mission.
The Canadians have done a lot of the robotics work, and obviously the space station's robotic arm has also been made by a Canadian company. So
that's correct.
Same when they made the boom.
That's exactly right.
So you're doing inspections on the inspection boom.
Exactly.
Okay.
We're doing additional inspections on the boom.
I'm sorry?
And once we're while we're working on Endeavour, getting Endeavour ready for the next flight, we're actually working in concert with the external tank and the solid rocket boosters and getting all of that prepared and ready for the next flight. So the external tank was actually delivered from Louisiana in late October. That was October 24th. And the the external tank, as you can see, arrived by barge, and it's offloaded and lifted into the vehicle assembly building in the checkout cell. And after a month of being in the checkout cell and undergoing inspections in the checkout cell, is actually lifted and in preparation for a mate with the solid rocket boosters. Now the solid rocket boosters have already been stacked and on the mobile launcher platform. And as you can see in some of this video footage here, where the external tank is lowered in between the solid rocket boosters. And once mated with the solid rocket boosters, undergoes checkout and ready for the orbiter mate operations.
Which is the beginning of what we're seeing right now.
Exactly. About 130 days of time in the orbiter processing facility, Endeavour was ready to roll over to the vehicle assembly building. And that's about a typical flow length. 130 days is about nominal. We go from 110 to 150 days. And this process of rolling Endeavour over to the vehicle assembly building takes about an hour. And you can see it was on an orbiter transporter system, so it doesn't roll over on its own wheels. It's on a transporter system. And then once in the vehicle assembly building, it's attached to a sling, a lifting sling, and they use a couple of cranes to lift the Endeavour up to about to the top of the vehicle assembly building in preparation for mate. And this mate operation that we're in the vehicle assembly building takes a couple of days. And on a typical basis, we stay in the vehicle assembly building for about 7 days for the checkout, for the mate with the external tank and checkout of the vehicle, make sure everything is working properly. But this was a unique flow for us. We actually stayed in the vehicle assembly building for about 25 days. That's not typical, but we did have the holiday break in there, so we had about 2 weeks of the holidays where we gave the team a break during the holidays. And
it's like you knew it was going to be a very busy year, so the teams get a little extra time off before.
And yeah, that's exactly right. We did want to try to give across the space center as a whole. We tried to give all of the teams off for about 2 weeks during preparation for this next year. And as you can see in this video, the orbiter is actually being lowered, and the mate process is undergoing. And once back from the holidays, on January 6th, Endeavour rolled out to, and the space shuttle vehicle rolled out to Pad A. And if you recall, back in early January, we did have some very chilly weather, and it was very unusual for us in Florida. We had a cold snap for a couple of weeks. But we did take some extra precautions to make sure Endeavour and the people that were working out there were kept warm. And it was chilly, but everybody survived, and it was a good operation that day.
I don't know whether it's coincidental or ironic or both, but tonight's going to be supposed to be a little chilly as well. Not anywhere near the temperatures we saw in early January, but
that's what we're hearing. It's going to be a little chilly tonight.
Seems good symmetry then, I guess.
Yes, we want to keep it chilly all January or February. So we spent about a month out at Pad A. Some of the major operations that we did were powering up the vehicle, loading the hypergolics and Endeavour, and doing some crew training as well. So this is, as you've probably mentioned, this is the 24th flight for Endeavour. And we're really glad to be here this evening and getting ready for this first launch of 2010.
All right, well, Dana, thank you very much for taking a couple minutes to talk to us and walk us through getting ready for this particular flight. Thank you, and again, that's Dana Hutcherson, the Endeavour's flow director. And we are currently at still holding at T-minus 3 hours. We're going to take a few minutes now to take a look at what's inside Endeavour's payload bay and what's going to be going to the International Space Station. And to do that, we have Joe July joining us, and he is the manager responsible for getting Tranquility and Endeavour's other cargo ready for the STS-130 mission. Joe, thanks for joining us.
It's an honor, Al. Good evening. How are you doing?
Well, let's get right to what you want to show us. Again, you've got some video. We just talked to Dana and showed us what it took to get Endeavour ready. Now you can tell us what it took to get Endeavour's payload ready.
Oh, fantastic. Let's do that. Can I see the video? Oh, there it is. Okay, well, I tell you, I want to say it's exciting to be here tonight. You can see in this picture, this is the Cupola being delivered to KSC, and it's really an honor to be here. We're going to talk a little bit about the Cupola. We'll talk a little bit about the node, and we'll show what it takes to process those and get them out to the pad. And this is really an historic flight. It's a special moment in history. We've been working with the European Space Agency and Theos Alenia Space Italy to deliver Node 3 and the Cupola, as you can see from this picture. So the Cupola is kind of unique. It's going to allow us to view space in all directions. when the robotic arm is being manipulated on station, allow the astronauts to have a clear view, and then also to take a look at our planet Earth and do some different types of IMAX cameras. So here we have the Beluga Airbus, and it delivered the node back in May of 2009. And the node is named Tranquility, and I like the name Tranquility. This was named after the Sea of Tranquility, which was the lunar landing site of Apollo 11 back in 1969. So since the node arrived at KSC, our purpose was to work with the European Space Agency and its partners to complete the integration and testing of the Node 3 and Cupola. So now the node's been offloaded and it's on its way to the Space Station Processing Facility. We'll work with ESA and our Italian friends, and we'll finish up the integration and testing of it. So here it's being removed from the canister. You can see one of the hatches, one of the actual hatches on the node, and that's actually the part where the cupola will be mated to, which we should show that to you in a couple minutes. So once, here's a good picture. Here's the cupola being integrated to the node. And once in space, the node's going to connect to Unity. And of course, its purpose is to provide additional working and living volume on the ISS. And as we mentioned earlier, the cupola is going to allow for a 360-degree view of the station and Earth, and to monitor robotic operations and observe our great planet. So here's kind of a unique task where we had to go very slow to make the cupola, check the sealing surfaces, make sure all the attach mechanisms are working, and attach the cupola to the node.
And the cupola, there are 6 actually docking ports on the side of all around, 4 on the sides and 2 on either end of Tranquility. And you notice on that one there was obviously cupolas being attached to one of the ends, but that's not its final resting place.
Exactly. So that's the cupola, what I call it the axial end, in order to fit inside the orbiter payload bay. Then once on orbit, the cupola will be moved from the end, if I can say the end of node, to the bottom of it, so we can view space station and our beautiful planet Earth. Okay, so here we have the node being lifted up. We're going to do a wait and CG and load into the canister and get ready to go to the pad. There's a great picture of the node on the axial port. The cupola on the axial port of node 3. So if you take a look at that, the node's about 24 feet by 15 feet, and the cupola is about 5 feet by 10 feet. And when we weighed those two items together, the two elements together, it was 33,325 pounds. This is about 8,000 pounds more than a nominal pressurized logistics module, but the node and cupola is going to be a permanent fixture on the space station. It has a lot of active components, electrical, plumbing, so we can work all the experiments and, of course, provide additional living space for the crew.
And the cupola itself, as a matter of fact, can hold. It's actually designed to hold 2 people at a time to be able to work inside there. Is that correct?
Yes, it's going to take 2 people to work inside between the computers and the mechanisms they have for the robotic arms. So here we have the canister. It went vertical in our rotation facility, and now it's on its long trip, or I guess short trip, depends how you look at it, to the pad.
This was done, if I remember correctly, in about mid-January.
Oh yes, it was done in mid-January, and it's kind of a, like I mentioned earlier, it's an interesting payload. And I think in a few seconds we'll actually see the node 3 and the cupola inside the payload changeout room, getting ready to be installed into the orbiter. Well, that's a beautiful shot. So we're going to lift the canister, we're going to hoist it up, make sure everything's secure. We'll open up the canister doors. We'll open up the payload doors, and we'll transfer the node 3 and the cupola into the pigum, and then eventually that will be put into the orbiter. It's a very delicate process, but we've done this for a few years, and so far it's worked out great. So another interesting fact of the Node 3 when it's attached. Oh, beautiful picture. There you go. So there's the Node 3 in the cupola inside the orbiter. And an interesting fact, Aled, is when this increases the working volume of ISS, it's going to allow us to have more than 100 what I call telephone booth size rack facilities for operating station and all the various research experiments. It's really going to enhance and fully utilize the International Space Station. And of course, inside the Node 3, we're going to be carrying up over 1,000 pounds of crew provisions.
All right, well, very good. Joe Delay, the STS-130 payload manager here at Kennedy. Thank you for joining us and taking a couple minutes to walk us through what's inside Tranquility and what's going up to the station. And it's right now we are still at T-minus 3 hours in holding. This is shuttle launch control at T-minus 3 hours in holding. Launch teams are not working any issues right now that would prevent us from launching on time this morning. And right now we take you to the operations and checkout building. We see the STS-130 commander, George Zamka, getting suited up. Finished up their weather briefing about 5 minutes ago and headed over to get their final suit up. Endeavour's pilot, Terry Virts, getting on their orange launch and entry suits. They're officially known as Advanced Crew Escape System, the ACES suit. Or as they affectionately refer to them as pumpkin suits. Bob Bankin will be the lead spacewalker for all 3 spacewalks on the STS-130 mission. A little more thumbs up, and perhaps because hearing the forecast this time around, things are more A-OK this time than they were last night. Mission Specialist Kay Heyer there, getting her helmet adjusted. Each suit technician from the Flight Crew Equipment Office assigned to each astronaut, 1 per astronaut. Nicholas Patrick there, almost on a knee there in the all smiles. He'll be also on all 3 spacewalks of this particular mission. First for him on spacewalks. And finally, Steve Robinson, the veteran space flyer of this particular crew, making his 4th flight. He'll be assisting the spacewalks from inside the space station. So as they pan around and look at the suit-up room, the operations and checkout building. Clearly in a little better spirits than they were last night, I think, based on the forecast and no other issues being worked. And there are the 6 astronauts for Endeavour's STS-130 mission. Making their way down the hallway in the crew quarters, followed by Jerry Ross, in charge of their, when they're down here at the Kennedy Space Center. He's 7-time flown astronaut himself. About to say goodbye in the elevator, but there we go. And there's the Astrovan waiting for the crew. The several other people who'll be riding along with the astronauts on the way to the pad, including Astronaut Chris Ferguson, the Deputy Chief of the Astronaut Office, will be doing the weather reconnaissance flights. They'll drop him off. And here's Endeavour's STS-130 crew. And you can see the head of the astronaut office, Peggy Whitson, along with one of the members of the closeout crew in the white overalls. And in that shot, you can see them. There's obviously a lot of media who are there to watch walkout, as it's known, and an awful lot of well-wishers, employees, friends, people who are obviously supporting the crews. That want to make sure that the astronauts know that they are behind them and want to wish them well before they head out to the launch pad and start their 13-day flight to the International Space Station. And the departure of the Astrovan, and of course the security escort. We're going to take a few minutes now to let you actually hear directly from the crew members themselves, from various aspects of their 13-day mission to the International Space Station.
So that's going to be my biggest job, is being responsible for space shuttle tasks and helping our commander with that. But once we get to the space station, I have a couple of important jobs. One of them is as a robotics operator. I'll be flying the shuttle robotic arm, mainly for inspecting the external heat shields to make sure that those are okay. Then I'll also be flying the space station arm along with Kay Heyer, one of my crewmates, and we're going to use that very large Canadarm2 to grab Node 3 while it's in the space shuttle payload bay, and we're going to remove it and attach it to the side of the space station. And then a few days later, we're going to grab the Cupola and remove it from one end of Node 3 and attach it to the bottom of Node 3.
Once we install Node 3 onto the port side of the International Space Station, we will configure the hatches and perform leak checks to make sure everything is in good shape. And then we'll be able to open the hatch between the International Space Station and Node 3 and go inside. When we first go inside, it's going to be dark because we don't have the electrical power all hooked up yet to the node number 3. So we'll go in with headlamps and portable lights to be able to start working inside of there. We're bringing up a lot of things stored in the node 3, and we strap it down very tightly for launch to make sure that it does not get damaged during the vibration of the launch. So we'll be unstrapping all that and configuring everything.
Generically, I think the tasks that we do during the spacewalks are each task in and of itself is not very complex. You know, we'll hook up an electrical line, or we'll take a cap off and then hook up an electrical line. The complexity comes when you realize that you'll be connecting up or interfacing with 10 different locations that have electrical lines on them, and keeping track of the 10 caps that are associated with that, and the 10 caps that are on the electrical line that have to go on to those locations as well. And so you start adding up these groups of 10, pretty soon you start saying or realizing that you have 50 or 60 things to keep track of in a bag as you go out and do your spacewalk. And so that's the complexity that you really see, is the stacking up of all the little bits and pieces that actually need to be accomplished to perform the outfitting of Node 3 and the Cupola.
That's another sort of sub-team. The EVA team, the spacewalking team, is sort of a sub-team within the crew. Mm-hmm. And so we've got Bob and Nick going outside. I'm inside, and my job is like an air traffic controller. You know, I'm basically taking them through their steps, helping them to be safe, making sure they stay out of hazards. If we run into something unexpected, which we will, then we work on it together, and I'm the guy that communicates with the ground, and it's very much like an air traffic controller, and we're all very comfortable with that model, and it's been great fun developing our skills all together as a sub-team of the crew.
I think the space shuttles will be remembered the way we remember the sailing ships of the past. Our Space Shuttle Endeavour is named after Captain James Cook's bark Endeavour, which was launched from the town of Whitby in North Yorkshire, about 5 or 10 miles from where I was born. And we look back on those ships today, and we're not so much impressed by what they can do in today's terms, but we're impressed by how much they did with them. And I think that's the way we'll look back on the space shuttle.
When we attach Node 3, the appearance of the station is going to change forever. So we'll be able to look at that station and be able to say, yes, we were part of that mission, and that station didn't look like that until we were there. And we will also leave the station in its final envisioned configuration, where the labs are for science and the environmental systems are housed for the most part in the nodes. So the space station will become what we have wanted it to be, a workplace for science and research with all the environmental systems that we need to sustain humans on board it for a long time.
And now we're back with police escort, obviously NASA security escort for the Astrovan as it heads out. And there is the Astrovan just outside in the background. You see the vehicle assembly building, and that is the launch control center right there. As we were talking about yesterday, this shot is from the direct angle of the press site, where media from around the world are gathered to watch and document the launch of Endeavour, the start of the STS-130 mission. One of the things that we all do here at Kennedy, and media do participate in this, do go out and wave to the crew, wish them well, as they take the last leg of their journey to the launch pad. Last 3.5 miles of that trip. And they'll begin the pulling up in the Astrovan to the launch pad surface, and then they'll be taking a ride up the elevator to the on the fixed service structure up to the 195-foot level. This is shuttle launch control at T-minus 2 hours, 33 minutes and 10 seconds and counting. You can see the 6 astronauts for Space Shuttle Endeavour's STS-130 mission have arrived at the 195-foot level on the fixed service structure at Launch Pad 39A, and they are making their way towards the hatch. And with them is the closeout crew, 7-person crew who will help actually get them into the shuttle. And we are fortunate to be joined now by Travis Thompson, who is the lead for the closeout crew. And Commander George Zamka expressing some confidence in launching.
Yeah, he looks confident and happy, and that's a good sign. We like to see that. And they're adjusting the harness. What happens in the suit room is they get their launch and entry suit on and their boots and everything, but when they get to the white room, the closeout crew has to don their harness, which will connect to the parachute. And it's got some survival gear in it and stuff like that. And it also is what they're going to be strapped into the seat. So they adjust and make all the fine adjustments in the white room so that when they crawl in, they don't have a lot more to do as they get into the seat level. And on the pad surface, we have to take those booties off. Looks like the commander's ready to go in.
And Bob Bankin's about ready to have his turn in the white room.
Yeah, and the white room is not, camera is kind of deceiving. It's not a big place.
No, it really isn't. It's the camera offers a very different perspective.
It does. And what we do is we try and get 2 of the astronauts suited up at a time. One will go to the flight deck, and the other will go to the mid deck.
And now, of course, you mentioned the flight deck of George Zampa getting into his commander position on the left-hand side of the flight deck.
That's quite a trick also. He's very good at it, but there's things you can hit, switches you could bump, and they do a real good job of it, but they practice. There's mock-ups in Building 9 out at JSC at Johnson, and they do this several times in their training. And those mock-ups are just like the real flight bird. Once they get that con cap on, it limits the astronauts' hearing in the white room. So a lot of times it seems like they're yelling at him. You got to speak louder. See, Bob will lean in to listen. That's what.
And OTC, OBCC. Go ahead, OBCC. Yes, ma'am. MS4 is aboard. MS4, copy.
That's closing crew member talking to the orbiter test conductor.
And GMT and MET adjustments are complete, ready for IMU platform positioning, step 647.
Confirming that George Zampa is on board.
Copy.
They have a timeline, and they write down the time each one enters the ship. Because like I mentioned, we are on 50-minute to get them strapped in, so they check to see each one crosses the threshold.
Now we see back in the white room. Terry Virts and both Nicholas Patrick.
And see, they shook hands because one's going to the flight deck, one's going to the mid deck, so they won't speak to each other
directly until I guess they get into space, right?
There you go. And Mike's back out there doing the check for PLT before he gets on board. Pilot.
So a successful communication check with George Zampa, not only with the Launch Control Center here in Kennedy Space Center, but also with the Mission Control Center in Houston. Now we could see, just for people who may be watching and never seen a suit up before, or wondering what some of the equipment that's on the flight suits that they have. You can see that Nicholas Patrick there on his right arm has a mirror. It's not for any vain reasons, it's practical.
Yep. They can look, hold that, look out.
Go ahead.
I can see him getting into the pilot's position up on the flight deck now.
Yeah, he has to take his time and make sure everywhere he puts his hand or his feet that see, he's taking his time getting in. He has to pull himself up.
OBCC. Go ahead. Yes, ma'am. MS3 is aboard. MS3, copy.
Confirming that Nicholas Patrick now is heading to.
GMT 0611.
heading to the middeck. Jim Kelly was telling us yesterday this is quite a juggling act to have all the flight suit and equipment on and then be able to position yourself up like that.
It is. I've actually got to experience that in the mock-up in Houston when we do our emergency egress training where we try and get a downed crew out. I wanted my guys to experience what it was like to wear a suit so that we would know what the astronauts are going through. The suit weighs around 60 pounds, and I wanted them to learn the mobility that they had and the comfort level. So we've worn the suits and climbed into the ship in the mock-up.
And speaking of Kay Hire,
Kay, as I mentioned, she was on the closeout crew also. She was a number 2. She's helped us tremendously over the years when she's down here as a C-square.
and you said you're currently a member of the United Space Alliance company as the closeout crew lead. Now we have mission specialist Steve Robinson. He making his 4th flight here.
I think I've got to help him in on 1 or 2. I think he and John Glenn flew on.
He did.
95.
STS-95, absolutely.
That was quite an experience for me, getting to see one of your childhood heroes. And you're doing what he was doing, putting him in. That was quite an experience.
Steve Robinson's last flight was on the STS-130 mission. That's NASA's return to flight mission following the Columbia accident. That flight, STS-114, was in 2005.
OTC, PLT, com check. PLT, this OTC, I have you loud and clear. How many? Loud and clear. Good morning, Alberta. Morning, Terry. CLSC, OTC.
OTC, go ahead.
643 through 646.
So it's not something that's actually expected to impact the launch. It's not something that's really an issue, other than the fact that because it's a hazardous operation area with a fully loaded external fuel tank, requires certified people to do that. That is the red team. So that's why a red team person is going to be running that flight data file out to the launch pad and getting it to Steve Robinson.
Yeah, they have to have the proper breathing apparatus, proper communication, and safety will come out with them. It's okay to have a red crew in the pad perimeter, but just not on the 195 because of the reason I told you.
Copy.
So we are looking now at the
OTC, MS3, contact. MS3, this OTC, I have you loud and clear. How many? You're loud and clear. Good morning, Roberta. Good morning, Nick.
And it's a good job on Chris Minert's part because he's utilizing his resources well, and things continued to work while he had to send people down, so we didn't lose any time. No hit, no foul.
Dr. Robinson now.
OTC, OVCC.
Go ahead.
Yes, ma'am. MS2 is aboard.
Copy, MS2 aboard.
Endeavour, Houston. For the entire crew, comm check.
CDR, loud and clear. CLT. MS1. MS2. MS3. MS4.
Endeavour, Houston, we read you all loud and clear. This completes the air-to-ground voice checks.
And attention all personnel, this is the NTD conducting the launch status check. Verify ready to resume count and go for launch. OTC? OTC's go. TBC? TBC's go. TTC? TTC's go. LPS? LPS is go. Houston flight? Houston flight is go. MILA? MILA is go. STM? STM is go. Safety console? Safety console is go. SPE? SPE is go. LRD? LRD is go. SRO? SRO is go. And CDR? CDR is go. And launch director NTD, our launch team is ready to proceed at this time. Okay, I copy that, Jeff. Thanks. I'll do my poll this time. KSC Chief Processing Engineer, verify no constraints to launch. No constraints. Thank you, Steve. Payload Launch Manager. Mike, Space Station Teams go. Good. Thank you, Bill. KSC Safety and Mission Assurance. KSC Safety and Mission Assurance will go, Mike. Thank you, Mark. Range weather.
Weather has no constraints for launch.
Thank you, Kathy. And Ops Manager. Let's see, Mike. Looks like we have acceptable weather conditions around the world tonight for what we need. Mission management team doesn't have any other issues on the plate, so you are go to launch Endeavour in Node 3. Okay. Thank you, sir. Endeavour Launch Director, Air to Ground 1.
Launch Director, this is Endeavour. Go ahead, sir.
Okay, Zambo. Looks like the weather came together tonight. The vehicle's in great shape, so it's time to go fly. Wish you good luck, Godspeed, and we'll see you back here in about 2 weeks.
Yeah, thanks, Mike, and thanks to the great team that got Tranquility, Cupola, and Endeavour to this point. And thanks also to the team that got us ready to bring Node 3 and Cupola to life. And we'll see you in a couple of weeks. It's time to go fly.
Roger that. Have a great ride. And with that, you are clear to launch Endeavour. Copy that. Thank you.
Countdown clock will resume in 5, 4, 3, 2, 1. T-minus 9 minutes and counting.
9 minutes and counting.
GLS auto sequence has been initiated.
Confirmation that the ground launch sequencer has been initiated. It means all countdown functions are now automatically controlled by this GLS computer that's located in here in the firing room. At the T-minus 31 second point, the ground launch sequencer issues a command to the 5 onboard general purpose computers. The redundant set launch sequencer or RSLS software. T-minus 8 minutes and 5 seconds and counting. Pilot Terry Verts is now setting switches in the cockpit to directly connect the 3 onboard fuel cells to the essential power buses in Endeavour. 3 fuel cells provide all the electricity for the shuttle while it's in orbit. T-minus 7 minutes, 30 seconds and counting.
GLS is go for orbiter access arm reset.
Endeavour OTC, let's start out the year with the delivery and installation of Tranquility and the installation of the Cupola, providing a breathtaking view of the Earth and giving you windows to the world.
You can see the orbiter access arm being moved away from the hatch of Endeavour. It's the walkway that the crew uses to get in and out of the shuttle, and can be returned into position within a few seconds if necessary. We're at T-minus 6 minutes, 30 seconds and counting.
OTC, start AQ display recorders.
JRPS, APU display recorder started.
TLT OTC perform AQ pre-start.
TLT in work.
Terraverse has been given the go-ahead to start the auxiliary power units. And the APUs provide pressure to the shuttle's 3 hydraulic systems, which move the main engine nozzles and the aero surfaces of the shuttle. T-minus 5 minutes, 55 seconds and counting.
OTC, TLT, restart complete, very great talkbacks.
Copy that, thank you.
Verifying that the APUs are up. We're at T-minus 5 minutes and 30 seconds and counting. T-minus 5 minutes and counting.
TLS is go for orbiter APU start.
TLT OTC perform APU start. CDR reconfigure heaters.
Terraverse has been given the go-ahead to start the auxiliary power units. The launch team has now terminated the liquid oxygen replenish to the external tank. It is now initiating the liquid oxygen drain back from the piping at the bottom of the shuttle. T-minus 4 minutes, 30 seconds and counting.
OTC, TLT, APU start is complete, 3 grain.
Copy, 3 grain.
Verifying that all 3 auxiliary power units are functioning well.
TLT, heater reconfig complete.
Copy.
We're at T-minus 4 minutes and counting.
TLS is go for purge sequence 4.
The final helium purge of the 3 main engines is now underway. Preparation for main engine start. T-minus 3 minutes, 30 seconds and counting. See the final aero surface checks being complete, and Endeavour's 3 main engines are being moved through a pre-programmed series of maneuvers. This final test before launch prove that they will do the steering that they need to get Endeavour into orbit. T-minus 3 minutes and counting.
TLS is go for ET LO2 pressurization.
We're going to go to begin the final pressurization of the external tank's liquid oxygen.
OTC, clear caution warning memory, verify no unexpected errors.
TLT in work.
T-minus 2 minutes, 30 seconds and counting. See the gaseous oxygen vent hood, also known as the beanie cap, is being slowly retracted away from the top of the external tank.
No unexpected errors.
Copy that, thank you.
Caution warning system has been cleared.
Flight
No
crew
issues there.
OTC, close and lock your visors and initiate O2 flow.
Endeavour has visors and O2 flow in work.
Copy.
We're at T-minus 2 minutes and counting.
TLS is go for ET LO2 pressurization.
The liquid hydrogen replenish on the external tank is now being stopped. And we are 90 seconds away from the launch of Space Shuttle Endeavour. T-minus 1 minute and counting. T-minus 50 seconds. Now transferring the shuttle's internal electricity. Endeavour is now being powered by its 3 onboard fuel cells. We're coming up on auto sequence start. T-minus 31 seconds and counting. Endeavour's 5 main onboard computers now have primary control of all the spacecraft's critical functions, including control of the countdown from here on out. T-minus 16 seconds. The sound suppression water system has been activated. T-minus 10, 9, 8, 7, 6, 5. We have scope ready to start. 2, 1. Here. Booster ignition and liftoff of Shuttle Endeavour, NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Flight to the International Space Station. 28 seconds into the flight, Endeavour flying at 1,100 miles per hour, 1.3 miles in altitude, and 7 miles downrange from the Kennedy Space Center, according to onboard computers. Endeavour's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
The 3 main engines on board are throttling back up, now 1 minute 10 seconds into flight. Endeavour flying at 1,800 miles per hour, 10 miles in altitude, 11.5 miles downrange. At liftoff, the fully fueled shuttle, boosters, and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. The next step will be the burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter towards space. Endeavour performance is as expected thus far. 2 minutes 19 seconds into the flight, Endeavour flying at 3,700 miles per hour, 35 miles in altitude, and 49 miles downrange. The propulsion officer confirms that the orbital maneuvering system engines are firing, providing Endeavour with its extra boost to orbit.
Endeavour, 2 engine Zaragoza.
Copy, 2 engine Zaragoza.
Now 3 minutes and 4 seconds into the flight, that call indicating Endeavour could reach Zaragoza in the event of a single engine failure. However, all 3 main engines continue to operate well. Endeavour's computers showing it flying at 4,600 miles per hour, 50 miles in altitude, and 98 miles downrange.
Endeavour, negative return.
3, negative return.
4 minutes and 3 seconds into the flight. Endeavour is now flying too high and too fast to return to the Kennedy Space Center and the shuttle landing facility in the event of an engine failure. Endeavour is flying at 6,000 miles per hour, 63 miles in altitude, and 180 miles downrange. Endeavour continuing on track.
Endeavour, you are pressed to ATO.
Copy, press to ATO.
5 minutes and 18 seconds into the flight. That call indicating Endeavour can now reach a lower than planned but a safe orbit on 2 engines should one fail, but all 3 engines are still performing well, as are the auxiliary power units and fuel cells.
Endeavour, single engine, ops 3.
Endeavour, copy, single engine, ops 3.
5 minutes, 50 seconds into the flight. Endeavour could conduct a transatlantic abort landing on 1 engine should 2 fail at this point.
Endeavour, single engine, Zaragoza.
Copy, single engine, Zaragoza.
Endeavour could reach Zaragoza on 1 engine should 2 fail at this point.
Endeavour, you are pressed to MECO.
Copy, press to MECO.
6 minutes, 22 seconds into the flight. Endeavour can reach the planned orbit on 2 engines. All 3 engines continue to operate well.
Endeavour Houston, your shutdown plan is nominal. Go for the +X, go for the pitch maneuver.
Nominal shutdown, go for the +X, go for the pitch.
Endeavour flying at 12,000 miles per hour now.
Endeavour, single engine press.
Copy, single engine press.
7 minutes, 8 seconds into the flight. Endeavour can reach its planned orbit on 1 engine should 2 fail, however all 3 still performing well. Endeavour is now at an altitude of 64 statute miles, 606 miles downrange. The 3 main engines are now throttling down to maintain structural limits on the orbiter as it passes or approaches loads near 3 times gravity. Seven minutes, 40 seconds into the flight. Eight minutes, 10 seconds into the flight. Endeavour continuing on track, all systems performing well. Booster officer confirms main engine cutoff.
Endeavour Houston, nominal MECO, ohms 1 not required.
Copy, nominal MECO, ohms 1 not required.
And the external tank has separated now. 9 minutes into the flight of the Space Shuttle Endeavour on STS-130, the crew will be preparing for handheld photography of that external tank with a plus X maneuver of the orbiter to position Endeavour correctly. Mission specialists Bob Benkin and Kay Heyer are quickly getting ready to capture that imagery.
T-minus 10, 9, 8, 7, 6, 5. We have approach ready to start. 2, 1. Here. Booster ignition and liftoff of Shuttle Endeavour, NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Mission Control Houston, Endeavour's roll maneuver is complete. So heads down position on track for its flight to the International Space Station. 28 seconds into the flight, Endeavour flying at 1,100 miles per hour, 1.3 miles in altitude, and 7 miles downrange from the Kennedy Space Center, according to onboard computers. Endeavour's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
The 3 main engines on board are throttling back up, now 1 minute 10 seconds in the flight. Endeavour flying at 1,800 miles per hour, 10 miles in altitude, 11.5 miles downrange. At liftoff, the fully fueled shuttle, boosters, and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. The next step will be the burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter toward space.
Six, 5. We have approach ready to start. 2, 1. Here. Booster ignition and liftoff of Shuttle Endeavour, NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
This is Mission Control Houston. Endeavour's roll maneuver is complete. So now heads down position on track for its flight to the International Space Station. 28 seconds into the flight, Endeavour flying at 1,100 miles per hour, 1.3 miles in altitude, and 7 miles downrange from the Kennedy Space Center, according to onboard computers. Endeavour's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
The 3 main engines on board are throttling back up, now 1 minute 10 seconds in the flight. Endeavour flying at 1,800 miles per hour, 10 miles in altitude, 11.5 miles downrange. At liftoff, the fully fueled shuttle, boosters, and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. The next step will be the burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter toward space. Endeavour performance is as expected thus far. 2 minutes, 19 seconds into the flight, Endeavour flying at 3,700 miles per hour, 35 miles in altitude, and 49 miles downrange. The propulsion officer confirms that the orbital maneuvering system engines are firing, providing Endeavour with its extra boost to orbit.
The sound suppression water system has been activated. We're T-minus 10, 9, 8, 7, 6, 5. We have stroke ready to start. 2, 1. Clear. Booster ignition and liftoff of Shuttle Endeavour, NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Flight to the International Space Station. 28 seconds into the flight, we're flying at 1,100 miles per hour, 3 miles in altitude, and 7 miles downrange from the Kennedy Space Center. Onboard computers.
GLS is go for main engine start.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
T-minus 10, 9, 8, 7, 6, 5. We have the program ready to start. 2, 1. Booster ignition and liftoff of Shuttle Endeavour, NASA's final space station crew compartment that brings a bay window view to our celestial backyard. The sound suppression water system has been activated. We're T-minus 10, 9, 8, 7, 6, 5. We have the program ready to start. 2, 1. Booster ignition and liftoff of Shuttle Endeavour, NASA's final space station crew compartment that brings a bay window view to our celestial backyard. Liftoff of Shuttle Endeavour, NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
This is Mission Control Houston. Endeavour's roll maneuver is complete. It's now in heads down position on track for its flight to the International Space Station. 28 seconds into the flight, Endeavour flying at 1,100 miles per hour, 1.3 miles in altitude, and 7 miles downrange from the Kennedy Space Center, according to onboard computers. Endeavour's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
The 3 main engines on board are throttling back up, now 1 minute 10 seconds in the flight. Endeavour flying at 1,800 miles per hour, 10 miles in altitude, 11.5 miles downrange. At liftoff, the fully fueled shuttle, boosters, and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. The next step will be the burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter toward space. Endeavour performance is as expected thus far.
Russian water system has been activated. We're T-minus 10, 9, 8, 7, 6, 5. We have the program ready to start. 2, 1. Booster ignition and liftoff of Shuttle Endeavour, NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
This is Mission Control Houston. Endeavour's roll maneuver is complete. It's now in the heads down position on track for its flight to the International Space Station. This is Mission Control Houston. Endeavour's roll maneuver is complete. It's now in the heads down position on track for its flight to the International Space Station. 28 seconds into the flight, Endeavour flying at 1,100 miles per hour, 1.3 miles in altitude, and 7 miles downrange from the Kennedy Space Center, according to onboard computers. Endeavour's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
The 3 main engines on board are throttling back up, now 1 minute 10 seconds in the flight. Endeavour flying at 1,800 miles per hour, 10 miles in altitude, 11.5 miles downrange. At liftoff, the fully fueled shuttle, boosters, and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. The next step will be the burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter toward space. Endeavour performance is as expected thus far. 2 minutes 19 seconds into the flight, Endeavour flying at 3,700 miles per hour, 35 miles in altitude, and 49 miles downrange. The propulsion officer confirms that the orbital maneuvering system engines are firing, providing Endeavour with its extra boost to orbit.
Endeavour, 2 engine Zaragoza.
Copy, 2 engine Zaragoza.
Now 3 minutes and 4 seconds into the flight, that call indicating Endeavour could reach Zaragoza in the event of a single engine failure. However, all 3 main engines continue to operate well. Endeavour's computers showing it flying at 4,600 miles per hour, 50 miles in altitude, and 98 miles downrange.
Endeavour, negative return.
Copy, negative return.
4 minutes and 3 seconds into the flight, Endeavour is now flying too high and too fast to return to the Kennedy Space Center and the shuttle landing facility in the event of an engine failure. Endeavour is flying at 6,000 miles per hour, 63 miles in altitude, and 180 miles downrange. Endeavour continuing on track.
Endeavour, you are pressed to ATO.
Copy, press to ATO.
5 minutes and 18 seconds into the flight. That call indicating Endeavour can now reach a lower than planned but a safe orbit on 2 engines should one fail, but all 3 engines are still performing well, as are the auxiliary power units and fuel cells.
Endeavour, single engine, ops 3.
Endeavour, copy, single engine, ops 3.
5 minutes, 50 seconds into the flight, Endeavour could conduct a transatlantic abort landing on 1 engine should 2 fail at this point.
Endeavour, single engine, Zaragoza.
Copy, single engine, Zaragoza.
Endeavour could reach Zaragoza on 1 engine should 2 fail at this point.
Endeavour, you are pressed to MECO.
Copy, press to MECO.
6 minutes, 22 seconds into the flight, Endeavour can reach the planned orbit on 2 engines. All 3 engines continue to operate well.
Endeavour Houston, your shutdown plan is nominal. Go for the +X, go for the pitch maneuver.
Nominal shutdown, go for the +X, go for the pitch.
Endeavour flying at 12,000 miles per hour now.
Endeavour, single engine press.
Copy, single engine press.
7 minutes, 8 seconds into the flight, Endeavour can reach its planned orbit on 1 engine should 2 fail, however all 3 still performing well. Endeavour is now at an altitude of 64 statute miles, 606 miles downrange. The 3 main engines are now throttling down to maintain structural limits on the orbiter as it passes or approaches loads near 3 times gravity. Seven minutes, 40 seconds into the flight. Eight minutes, 10 seconds into the flight, Endeavour continuing on track, all systems performing well. Booster officer confirms main engine cutoff.
Endeavour Houston, nominal MECO, ohms 1 not required.
Copy, nominal MECO, ohms 1 not required.
And the external tank has separated now. 9 minutes into the flight of the Space Shuttle Endeavour on STS-130, the crew will be preparing for handheld photography of that external tank with a +X maneuver of the orbiter to position Endeavour correctly. Mission specialists Bob Bankin and Kay Hire.
T-minus 16 seconds. The sound suppression water system has been activated. We're T-minus 10, 9, 8, 7, 6, 5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
This is Mission Control Houston. Endeavour's roll maneuver is complete. It's now in a heads down position on track miles per hour, 1.3 miles in altitude, and 7 miles downrange from the Kennedy Space Center, according to onboard computers. Endeavour's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
The 3 main engines on board are throttling back up, now 1 minute 10 seconds in the flight. Endeavour flying at 1,800 miles per hour, 10 miles in altitude, 11.5 miles downrange. At liftoff, the fully fueled shuttle, boosters, and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. The next step will be the burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter toward space. Endeavour performance is as expected thus far. 2 minutes 19 seconds into the flight, Endeavour flying at 3,700 miles per hour, 35 miles in altitude, and 49 miles downrange.
Sound suppression water system has been activated. We're T-minus 10, 9, 8, 7, 6, 5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Houston, Endeavour, roll program.
Roger, roll, Endeavour.
This is Mission Control Houston. Endeavour's roll maneuver is complete. It's now in heads down position on track for its flight to the International Space Station. 28 seconds into the flight, Endeavour flying at 1,100 miles per hour, 1.3 miles in altitude, and 7 miles downrange from the Kennedy Space Center, according to onboard computers. Endeavour's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
The 3 main engines on board are throttling back up, now 1 minute 10 seconds in the flight. Endeavour flying at 1,800 miles per hour, 10 miles in altitude, 11.5 miles downrange. At liftoff, the fully fueled shuttle, boosters, and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. The next step will be the burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter toward space. Endeavour performance is as expected thus far. 2 minutes 19 seconds into the flight, Endeavour flying at 3,700 miles per hour, 35 miles in altitude, and 49 miles downrange.
T-minus 16 seconds. The sound suppression water system has been activated. We're T-minus 10, 9, 8, 7, 6, 5. We have flow from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Houston, Endeavour, roll program.
Roger, roll, Endeavour.
This is Mission Control Houston. Endeavour's roll maneuver is complete. It's now in a heads-down position on track for its flight to the International Space Station. 28 seconds into the flight, Endeavour flying at 1,100 miles per hour, 1.3 miles in altitude, and 7 miles downrange from the Kennedy Space Center, according to onboard computers. Endeavour's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
The 3 main engines on board are throttling back up, now 1 minute 10 seconds in the flight. Endeavour flying at 1,800 miles per hour, 10 miles in altitude, 11.5 miles downrange. At liftoff, the fully fueled shuttle, boosters, and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. The next step will be the burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter toward space. Endeavour performance is as expected thus far. 2 minutes 19 seconds into the flight, Endeavour flying at 3,700 miles per hour, 35 miles in altitude, and 49 miles downrange.
Sound suppression water system has been activated. We're T-minus 10, 9, 8, 7, 6, 5. We have flow from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Houston, Endeavour, roll program.
Roger, roll, Endeavour.
This is Mission Control Houston. Endeavour's roll maneuver is complete. It's now in a heads-down position on track for its flight to the International Space Station. 28 seconds into the flight, Endeavour flying at 1,100 miles per hour, 1.3 miles in altitude, and 7 miles downrange from the Kennedy Space Center, according to onboard computers. Endeavour's engines are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Endeavour, go at throttle up.
Endeavour copies, go at throttle up.
The 3 main engines on board are throttling back up, now 1 minute 10 seconds in the flight. Endeavour flying at 1,800 miles per hour, 10 miles in altitude, 11.5 miles downrange. At liftoff, the fully fueled shuttle, boosters, and external tank weighed 4.5 million pounds. The total thrust at launch was 6,425,000 pounds. All systems continue to function well. 3 good main engines, 3 good power generating fuel cells, and 3 good auxiliary power units for the hydraulic system. The next step will be the burnout and separation of the solid rocket boosters. Combined, the twin boosters provide 5.3 million pounds of thrust to propel the orbiter towards space. Endeavour performance is as expected thus far. 2 minutes 19 seconds into the flight, Endeavour flying at 3,700 miles per hour, 35 miles in altitude, and 49 miles downrange. The propulsion officer confirms that the orbital maneuvering system engines are firing, providing Endeavour with its extra boost to orbit.
Endeavour, 2 engine Zaragoza.
Copy, 2 engine Zaragoza.